So, hello and good afternoon. So my name is André. Today I'm going to talk about knowledge graphs and FAIR principles applied to social science and humanities on SSHOC-NL project. So a little bit of myself first. I born in Brazil. I did my PhD in the semantic web area here in Leipzig, with the majority of these guys here. So and now I'm working at the Vrije University of Amsterdam, applying semantic web to social science and humanities. So and I'm the organizer of SEMAT's workshop as well. So quickly talking. So a little bit about the group that I work, the UCDS, User-Centric Data Science. So the research topics include cultural heritage, linguistics, FAIR principles, digital humanities, and more, and semantic web apply in diverse areas, including social science and humanities. You can check more on the website. So I have bachelor students like in this area. I am a postdoc there, just make sure that you understood. So in link prediction, FAIR tools, doing benchmark, ontology alignment, benchmark and comparison of ontology and vocabulary repositories, all focused in data from social science and humanities. And so we have some projects here, like and the project that I'm working actually now is SSHOC-NL, Social Science and Humanities Open Cloud. So it's semantic web plus FAIR data applied to social science and humanities. So these are the people that I work with, okay? And so the project that I'm working with is SSHOC-NL. So the aim is to facilitate the FAIR principles to social science and humanities. So we do like annotation and search, like majority of the tasks include like conversion of tabular data to RDF, query with natural language and LLMs, like with those models, and creating link sets between like common data, like for instance, like the most common right now is Wikidata with some particular data from social science, and providing APIs including SPARQL endpoints, using the linked open data model, use like standard vocabularies and ontologies in order to get this interconnection between this heterogeneous data. And we have a service specific for social science and humanities that is Claria, where one of the aims is to identify missing vocabularies and provide a kind of like registry and repository for those vocabularies. Because, for instance, like in social science, the majority of people like don't use OWL, they use course. So instead of like to have classes, we have like concepts, and they don't have subclasses, narrow or broader, and so on. This is a kind of like small stuff from this domain. And the deliverables from the project includes a knowledge graph, which I'm working the majority of my time, and requirement analysis, visual interface, and quality assurance. A little bit of the knowledge graph that I'm working with. So the main plan for this is to develop an initial proof of concept of this knowledge graph, where the key aspects are like the model, the academic ecosystem in social science and humanities, and in order to capture those relationships between researchers, data sets, research software, and research papers. So we use this publicly available data only, and and we, as a good practice in semantic web, to use persistent identifiers such as like DOIs for papers and dataset, ORCIDs for authors, and so on. More information you can read our data store about this knowledge graph. So where the data comes from, like from in this knowledge graph. So mainly we deal with private tabular data. Means like comes from CBS. CBS is a Central Bureau for Statistics in Netherlands. So, and to deal like with this, we need to have the like annotations on this private data. And if the people want this data, they need to fill a form and so on. And we have some code from some projects like Odyssey, where this SSHOC-NL comes from, and some repositories and tabular data also that comes with vocabulary and thesaurus and so on. So some recent activities that we are doing there, for instance, like comparing FAIR tools with FAIR implementation profiles. Two different things, like FAIR tools, like they aim to provide you an automatic way to check if like your data is fair, like apply the FAIR principles or not. And the problem here, like we have like the same data set and different results according to the tools and according to the questionnaire also. So, and these questionnaires, this FAIR implementation profile, they are community oriented. So these grow up with social science and humanities, this FAIR implementation profile. And we are dealing like this. This was a paper published at LSWT like last week. And that's all. So, and another one is like making closer data fair. The case of CBS data, where they have like private tabular data and public metadata. So, like the aim here is like to annotate the columns of this private data, providing metadata. So then, like in this way, like the data don't need to be open, but can be fair, can be like the FAIR principles can be applied to this data. Okay. Another one is it's work from a PhD student, which starts with ontology alignment with LLMs and knowledge graphs. So he has a approach with 5 steps, like with involving embedding creation, like training sets of some models, and one case here that we got, the first one, is providing a kind of crosswalk, like matching like properties from code meta to Wikidata. And I am one of the organizers of the SEMAT workshop, so which is a workshop aiming to join people like from semantic web and material science. So it's the second edition this year. So if you have some work in semantic web and material science, as the case of the previous presentation by Miriam, so this is a kind of your chance to have a place to talk about your work and discuss. So my former work was applying semantic web to material science, so at Bonn. And the workshop, more hands-on, where the aim is like to create and find like reusing vocabularies in humanities and social science. So the name is Let's Talk FAIR, So this happened last week, was in Amsterdam during the conference DH Benelux, Digital Humanities Benelux. And we got like 2 recent papers. I would just talk about the most recent papers, of course. So one of the was the Best Paper Award, which is this enhancing provenance research with linked data, visual approach to knowledge discovery. So it was at the CMDH workshop. And that's all, and we are always open for collaboration and studies together. And I appreciate your time. Thank you.
Okay, are there any questions from your side?
Thank you for the talk. I have one question. You mentioned the ontology alignment.
Yeah.
And I was wondering if you have these closed data sets in the Excel files. I mean, if you want to match them then to ontological concepts, which you already saw, this is huge work if you do it manually. And I was asking myself if you use LLMs or other systems to help support you by the matching, through the matching.
Oh yeah, sure. Thank you for the question. Very relevant. So the relevance of this question is about you using LLMs in many tasks. For instance, ontology alignment. So our previous work, we are using LLMs to generate, to complement ontologies for material science. So, and then we realized that since we are generating this, it's not link prediction, just to make clear, but we realized this, and for a small ontology, LLMs works good. Huge data, I don't have the answer yet. Maybe we'll have in next month, but just to make clear that I point to your question. My pleasure.
Yeah, thank you, André.
Oh.
There's another
one. You mentioned there was a research paper for this, I think. Is that public?
Oh, no, I mean if you want a very good research paper about ontology match and ontology alignment using LLMs and RAG, there's the best research award from LSWT. It was just published last week. It's called OntoAligner.
OntoAligner, is that right?
OntoAligner.
All right, thank you.
Yes, definitely. And our work is a little bit different because we focus straightforward in data from social science and humanities. And this matter of because people majority use scores, and this makes all difference when we are talking about this. Just to make sure that. Are you satisfied?
Yeah, that's fine. Thank you.
Perfect.
Thank you for your presentation. My question is, for every project there is a major constraint, right? So I want to know, you spend more time for this constraint and how you find solution for that.
More time for this constraint.
Yeah, constraint, the theory of constraint, when you have something takes a lot of time. So, yeah, what's the part that it takes more time for you for your design? Thank you.
You mean only about the ontology alignment, or you want to talk
the process? Yeah.
This one.
Yeah.
I mean, the constraint that takes more time is to compare with the state of the art. As I mentioned that we this Onto a liner from the last week. So, and we were working in the kind of similar way. And then like, boom, ontoliner comes. And then we need to rethink all this stuff. This will take like, I don't know, like the student got a little bit like, how can I say, disappointed. Because like, it was a kind of competition, you know, like, but then like, as a supervisor, you need to explain that this is not a kind of competition. Like the science needs like some approach in parallel, and then like just to answer you in a kind of very vast way, like this constraint of time. So this constraint of time, that there's no like exact answer, like it's this way, we have the methodology. I mean, I can only say about my case, but there's no formula, generic, universal, accepted by the whole world. No, but my case is this one about time constraint. Only my case. I don't think I answered your question, definitely not, but...
Yeah, because I have experience in research and industrial life, so always we try to detect time to market. Mm-hmm. So what's the part that we spend a lot of time, because it helps a lot for the business plan and for the approval with our client. The client can be a university, can be a company, so just to have an idea. Thank you.
Okay. No, I mean about like those type of time constraint, like to, for instance, provide a kind of product to a company. So this can be planned, of course, like because we can have a prototype and so on. But we are talking about more a kind of proof of concept here. Just make sure that.
Yeah, thank you.
Got it.
All right. Thank you.
Pleasure.